Welcome back to Narrate Talks, the podcast dedicated to the future of resilient manufacturing. Today we are shifting gears from why of resilience to the how of self-adaptation. In our first episode, we discussed the disruption that threatened global supply chain. Today we are exploring how Narrate project moves beyond simple monitoring to create a system that can actually respond. We are talking about smart manufacturing networks, or SMN, ecosystems that are just not connected but self-orchestrated and programmable. Our goal for today is to pull back the curtain on the enabling technologies like AI, IoT, and digital twins that allow a supply chain to act as a living entity. We want to show industry leaders and researchers how these tools unlock deeper intelligence and allow for real-time reconfiguration when the unexpected happens. We have a heavy-hitting technical lineup today to break down this complex architecture. Joining us from ServTech is Professor Mike Papazoglou, whose foundational research has shaped the global standards for cloud engineering smart manufacturing. With over 250 publications and a career dedicated to the leading and major European research initiatives, Mike is currently spearheading the development of resilient smart manufacturing networks within the Narrate project. Professor Armand Baboli joined us from INSA Lyon, where he collaborates with the Narrate project's work, a pioneer in transforming traditional manufacturing into Industry 4.0 systems. Armand's decision support tools are already powering real-world industries, making him critical architect for the project's manufacturing as a service vision. Jesús Ávila Molina is the IT and Services Project Director at NUNSYS, where he spearheads the Narrate project's integration of digital twins and machine learning. With over 25 years of international experience, including a dedicated long tenure leading critical system and BP refinery, Jesús is a master at aligning complex IT infrastructure with industrial innovation. Representing Reply, Maurizio Griva brings over a decade of high-level management experience to the Narrate project's research initiatives. As a specialist in business development for IoT and cloud computing platforms, Maurizio oversees the integration of smart onboard systems that allow manufacturing networks to think and react in real time. Mike, let's start with the foundation. Tell us about the design and development of digital twin and data contextualization.
Welcome back to our podcast on supply chain resilience. Today, we explore two core concepts at the heart of Narrate: digital twins, what we call blueprint frames, and contextualization. Don't let the terminology sound complex. If you understand manufacturing, you already understand the logic. Let's ground this in a concrete example. As a matter of fact, a pilot from the project Narrate, and this is bespoke baby cot manufacturing, which is a use case in Narrate, in fact. Imagine a company producing customized baby cots. Each order may differ in size, certified wood type, finish, safety features, decorative elements, sustainability constraints, or delivery urgency. One cot might require certified oak from a specific region, for example. Another may need hypoallergenic coatings for medical reasons. And a third one might be an urgent hospital order. So let's add some disruptions. A timber supplier faces shortages. Imported fittings are delayed. Regulatory update introduces new safety requirements. Traditionally, when we're dealing with situations like that, companies respond reactively. Phone calls are made, meetings happen, but spreadsheets are created and circulate. Decisions are taken under a lot of pressure. Well, Narrate asks a different question. What if we could see risks forming before they hit production? In Narrate, we do not create just one digital twin of a factory. We create a set of structured digital representations that act as intelligent digital mirrors of different aspects of the manufacturing ecosystem, and these are called blueprint frames. In bespoke coat manufacturing, we model blueprint frames for suppliers, So here we talk about reliability of a supplier, geographic exposure, sustainability credentials, and so on and so forth. We talk about products. A product contains variants, materials, compliance requirements, and so on. Production, where we talk about capacity, scheduling, workforce availability. Machine, for example, we talk about CNC, or computer and numerical control machines, which control movement, cutting, shaping, or drilling. Sanding stations, painting lines, health status, energy usage, and so on. Then we talk about logistics, routes, lead times, warehousing constraints, and finally, sustainability, carbon footprint, recyclability, circularity. And these are some examples of blueprint frames. There exist more, but I'm not going to delve into them. So each blueprint frame captures one dimension of reality in a structured manner. For example, if a CNC machine cutting customized cut panels shows vibration anomalies, then the Narrate Intelligent Manufacturing Custodian does not just raise a maintenance alert, it understands which configuration, cut configuration, in fact, depends on that machine, which materials are already allocated, which customer deadlines are affected, and so on and so forth. This transforms isolated data into operational intelligence. So blueprint frames enable manufacturing as a service, supporting a self-orchestrated smart manufacturing network. So if we talk about resilience, it certainly doesn't come from raw data. It comes from data which carry meaning. Imagine a timber supplier reports a delay. On its own, this is interesting. This is just a notification, though, a red flag in a system. But what does it actually mean? If the delay affects standard cut models with high inventory, then the impact is small. If it affects customized neonatal cut due to a hospital order in 2 weeks, the impact is critical. But if that supplier serves multiple manufacturers, then the risk becomes systemic. The difference isn't the data, it's the context of the data. In Narrate, contextualization happens by linking blueprint frames. The supplier connects to the product connects to the production frame, production connects to logistics, and sustainability spans across all of these blueprint frames. So instead of isolated signals, we see an interconnected system or an interconnected network of blueprints, one that can simulate consequences before disruption spreads. But for that to work, systems must understand each other. Manufacturers rely on ERP systems, MES platforms, IoT sensors, and logistics tools. All of those are speaking different digital languages. That is where FDIF, the Federated Digital Interoperability Framework that we are developing in Narrate, becomes essential. FDIF asks as a semantic glue of the smart manufacturing network. It enables these heterogeneous systems not only to exchange data, but to interpret it consistently. Without FDIF, alerts stay fragmented. With FDIF, signals become coordinated insights. So if a geopolitical disruption affects a timber-producing region, the network can instantly connect the dots. Impacted suppliers depend on code configurations, production schedules, customer orders, and even sustainability implications. The result is simple but powerful: shared intelligence without sacrificing data sovereignty. That is the shift from isolated alerts to anticipatory resilience. Now, if we start bringing all these things together, we can imagine a storm that damages infrastructure in a region supplying certified oak. In the traditional system, procurement might detect delays days later. Production feels the shortage when stock runs low. In Narrate, though, the supplier blueprint for a lead manufacturer detects rising risk possibilities. The blueprint management system links that risk to specific code configurations and potential suppliers. The production blueprint simulates alternative material scenarios. The sustainability blueprint evaluates compliance impact, and the logistics blueprint finally recalculates lead times. So within a short time, management receives different options. Switch to an alternative certified supplier, procure alternative product parts and materials, prioritize hospital orders, adjust warehousing and logistics strategies. This is no longer reactive firefighting. This is proactive orchestration. And importantly, Narrate builds on existing systems. It does not replace them. Blueprint frames structure reality. FDIF connects and contextualizes it. Together, they can create a smart manufacturing network with shared visibility and coordinated decision-making. To recap in simple terms what I said so far, a digital twin shows you what is happening. Contextualization explains why it matters, and FDIF connects everything so that you can act intelligently. This integrated visibility is transformative, and implications go far beyond costs. Any manufacturer facing complex supply chains, regulatory requirements, customization, and global risk can benefit from this approach. So in other words, we can have multiple pilots which are diverse, which use the context of Narrate and the tools that I have described so far. So Narrate is not just about detecting disruptions. It is about understanding production-related relationships and tuning that understanding into resilient action. So this is the power of digital twins, blueprint frames, contextualizations, and FDIF working all together. And that is how we move from uncertainty to intelligent resilience. Thank you for listening. In our next episode, we will explore how AI strengthens this ecosystem even further.
Fascinating. So once we have the data contextualized, we need to make decisions, right? So Armand, how do the AI-driven methods for production planning and smart manufacturing network configuration works?
Hello, everyone. I think it's important to talk about the objective we have in work package 4 and specifically about AI-driven decision making. So first, we talk about consideration and management of disruption events, and particularly in operational level and not in the strategical level. So, the objective is also to find the solution and to propose appropriate solution when a disruption event arrive. So, disruption event could be considered as transforming a stable production system into an unstable one and required rapid readjustment. So a disruption event could be internal, for example, machine breakdown, material handling failure, worker absenteeism, quality issue. It could be also external disruption, such as supplier failure, delay, or transportation problems. Such disruption are especially critical in make-to-order context and specifically on mass customization system. So, solution may involve also internal action such as replanning or rescheduling of our production activity, or external action such as changing transportation mode, activating alternative supplier, or reallocation of capacity to our existing supplier. It could be also interesting to study the new paradigm as manufacturing as a services, allowing us to have additional flexibility. So this alternative solution must not only maintain the performance of production system, but also consider other criteria, aspect constraints such as resiliency, sustainability, cost, service level, all simultaneously. So we have several key points to address in our side. We focus mainly about package 4, considering how we can consider all these objective, constraint, facility, and uncertainty factors and generate a feasible solution, robust solution in a very short reaction time. The second question is the possibility of predict some disruption and proactively find the solution. And sometimes maybe it's not possible to change to proactive approach. If we have to remain in reactive approach, what could be the appropriate solution when a disruption event arrives? So traditionally, we address this kind of problem by first a mathematical model. We transform a business model into mathematical model, and when industrial condition change, it's so hard to adopt the mathematical model and add the modification. We need to have the expertise about coding, about mathematical modeling, and so on. That's why AI-driven decision support system can make a difference from traditional model. So in work package 4, the lead by INSA, we address several challenges. Two main challenges in this work package concern the decision making. Specifically, the first, and we developed the module for these problems. First problems concern the planning problem. First module focus on production planning under disruption. And the second module focus on logistic network reconfiguration and finding, for example, the new supplier and transportation mode. So each problem is initially formulated as an advanced mono or multi-objective optimization model, and the model acts as a decision agent, able to generate feasible and optimal solutions. We don't want to have just one solution. Generally, we generate the appropriate solutions, and by the interaction with with decision maker, we can select the appropriate one. So we introduce also an intelligent process called feedback process AI agent. This agent interacts with decision maker and learn about the preference of decision maker and adjust the parameters. It also could change the decision process and decision constraint if necessary. So, in other words, the system evolves dynamically instead of remaining in a static aspect. Or tools and modules are connected to intelligent manufacturing custodian and blueprint in order to receive and exchange the data and knowledge in real time and monitor the user interaction. So another key element in explainability through the IMC interface, decision maker can understand why a decision is proposed and what trade-off are involved for each decision. Another point is related to the advantage and disadvantage of each solution and how resilience and sustainability are impacted for each solution. In summary, our contribution in Work Package 2 is to move from static optimization toward an adaptive AI-enhanced and interactive decision-making framework capable of handling operational decision in complex manufacturing network. Thank you very much.
We have the model and intelligence. Now we need the custodian to manage it all. So, Jesús, can you walk us through the implementation of the IMC and the role of the NSQA DSS?
Hello, everyone, and thank you for watching this webinar series. Now it's the turn of the IMC, the Intelligent Manufacturing Custodian. The IMC is the brain of the whole Narrates platform. It stands in the center of the platform, listening to user questions via chat window or events or alerts triggered from anywhere in the network. It is composed mainly of an orchestrator and a planner. For an incoming question or an event, the planner will make a plan of all the actions required to finally provide the most suitable solution to the decision maker, which at the end of the day is the user on the other side of the screen. The orchestrator on the other side will take the plan and execute one by one all the actions defined in the plan. Every action will generate output data, which will serve as input for the next action to be executed. Along the planner and the scheduler, we have agents connecting the several tools in the Narrate ecosystem, each one of them providing specific functionality. They all provide expert analysis and knowledge in several areas, like production planning, process routing, risk assessment, intelligent logistics, NSQA, blueprints, etc., being the plugins of the IMC's brain. One of the mentioned modules is the NSQA, the Neurosymbolic Question and Answering System. The NSQA is a decision support system using a semantic parser and a neurosymbolic reasoner for knowledge-based question and answering that empowers the user with a tool to extract knowledge for making the right decisions afterwards. So the aim of the IMC plus the NSQA and the rest of the tools is to provide potential solutions based on the questions or event received and the information gathered from the different tools to help the user decide what to do in every scenario. The NSQA uses the platform library, a repository containing risks, rules, and response plans. There are two ways that the planner can create a plan. The first one is when we have rules and response plans that will guide the planner to create the right sequence of tasks. The second one is when we don't have any of those guidelines and we have to create the plan dynamically from scratch based on the tool's specifications and the data gathered in every action of the plan. So, for example, some rules could be like when you don't have the stock of component C1 to produce the product code A, look for products similar to C1 from other suppliers. Or a second rule could be prioritize the search for alternative components by cost and geographic location. Or even a third one, prioritize the search with components that we have used in the past. And then we have response plans. For example, in the case of a supplier issue, there is associated a supplier delay plan, which will handle delayed supplier deliveries. This plan could have a sequence of actions like first, check all the orders and find the affected ones taking the product ID and work order ID. Second action, which with the product ID, get the components and materials required to manufacture that product ID. And the third one, search for all the suppliers that can provide the material or component using the material ID, component ID, and work order ID. Finally, with all the data, propose the best potential supplier to prevent disruptions. So those three actions would compound the response plan that would be stored there in the platform library. So bringing that up all together, since we started talking till now, I'm taking the scenario that we have rules and response plans, the sequence starting from the user until the user receives a final answer could be. So first, the user asks the question, give me information involved in delayed orders and include their work orders. Then the planner requests the NSQA to check if there is a risk type from the question and return the response plans related to this risk type and the rules, if any. If it finds a response plan, the planner will elaborate the final plan and send it to the orchestrator. The orchestrator executes the actions in the plan. As you see, we are all the time in the IMC area. So the IMC has received that question. Internally in the IMC, we've got the planner and the scheduler, the planner and the orchestrator, and the planner talks to the NSQA. Okay, so full step, if there is no risk, if the NSQA doesn't return any response plan, then the planner needs to create a new plan using all the information we referred before. And the orchestrator will execute that plan. Once all the actions in the plan are executed, the NSQA analyzes all the information shared by the orchestrator and creates a response which is shared with the IMC. So finally, the IMC returns the answer to the decision maker. In case the question would have been triggered by an alert, the solution would have been stored in the platform library for a later review. So, till here, we've talked about the process. But before finishing this webinar, this talk, I would like to share the main functionalities that we have in this NSQA. So, the NSQA acts as it narrates neurosymbolic module using ontologies and knowledge graphs to interpret structured supply chain knowledge. Then it identifies the risk type in the user's question and selects the corresponding response plan. Then provides the appropriate plan from its rule and plans library to the planner. If no plan exists, it alerts the planner so a new plan can be generated from scratch. It leverages ontologies and knowledge graphs to understand real relationships among orders, products, components, suppliers, and stock level based on the Mason standard. Interprets and analyzes data returned by the orchestrator. It builds the final response, integrating IMC data, detected risks, ROS, and expert knowledge. And then finally recommends decisions or next actions based on risk analysis and the context of the user's query or event. And finally, enhances transparency, explainability, linking risks, disruptions, mitigation strategies, plans, actions, and the impact across the SMN. And I really hope that with this small talk, the IMC and the NSQA gets clarity on all this narrates ecosystem. Thank you.
To wrap up the individual perspective, we need to talk about the infrastructure. So Maurizio, how does the edge cloud environment support these IoT demands and keep the AI integrated?
Good morning. I'm here to complement the interesting podcast sections of my colleagues before writing and supporting on the concept of IoT and the edge cloud IoT and integration with AI and how this can be at the very bottom of the work that is delivered by the IMC. IoT is indeed at the core of many manufacturing systems and setups. In fact, it's considered the backbone for the Industry 4.0, and now we can consider it as a consolidated subsystem of any modern OT IT infrastructure. Any mature IT platform should be able to connect machinery, logistics, CNCs, and any sensor that can be put in the shop floor, manufacturing, and transportation systems in order to create a streaming of data, which indeed are the blood of real-time data, and provide to historians and machinery and edge devices and analytics, which includes more and more AI agents or AI functions that are fitted by this systems. So the IMC should natively take advantage of such data flowing out from the shop floor and from the logistics, and support the planner to create response plan, to activate response plan, and possibly provide also a level of semantics that can not only give raw data, but also alert, which is different from raw data because there is a level of interpretation and even more complex scenario information that can supply the answer. So single sensors can identify and detect potential supply chain disruptions the asset tracking, for example, track location and conditions of goods and assets, and also their movement inside a supply chain. They can monitor environmental conditions, traffic, and weather monitoring. And they need to be, as much as possible, reliable and provide continuous data into the IMC. So from one point of view, they are the real-time heartbeat of the entire small supply manufacturing network, but also they can act as a criticality as they are lose to provide a continuous information into that. There are challenges in deploying an IoT platform. First of all, the applications can be must be flowed and moved from the really close IoT to the systems up to the on-prem or on-cloud or far edge or on-edge systems, which are different places where applications can be executed and data can be collected in order to be reliable and efficient in the execution. So, for example, a computer vision system could need a further observation detail for generating an alert when some boxes are damaged, and they can require to a cloud edge system an application which are not yet delivered, and the cloud edge system should deliver that application the closest to the camera as possible. Of course, that could involve also operations and AI that could be executed by GPUs, so not all the GPUs could be available and not for continuous timing. So all these components and constraints need to be taken into account in order to provide the IMC reliable data on a continuous basis and also execute and respond against the IMC further requirement of information if needed. So the AI here plays a role at different levels, and they must be distributed properly on the relevant side. In Narrate, we will exploit an open source platform for IoT, which basically provides buffering and continuous data. So in case of disruption at sensor level, they can collect those data and provide, let's say, averages over time or less than optimal information, but avoid a complete loss of such data. And also we will exploit a edge orchestrator in order to be able to move the proper applications and data closest to the place where they are generated and making them available to the IMC. So let's stay connected for the next podcast, where we will deep dive a little bit into the how a cloud edge platform can be used by IoT, and how this IoT will also enable a sovereignty of data and applications, being the one of the constraints that such relevant data are kept secure and under the ownership of the owner or the European, at least, clients.
It's incredible to see how these pieces, digital twin, AI, IoT, snap together to create a self-adaptating network. I would like to ask, Mike and Armand, you talk about digital twins and AI. For someone who isn't tech expert, how does having these tools actually help make better decisions in real time?
Yeah, basically, what I would say here is that these tools are very helpful in the sense that they provide information, holistic view of things and information to the user. So what they try to do is help the user solve particular problems regarding disruption or critical disruption, to be more precise, by providing him or her with a wealth of information. For example, if we take the pilot that I was presenting earlier, the cot manufacturing, then if you have, let's say, for example, a supplier who doesn't supply on time or supplies inferior material, or the wood has some, let's say, inherent problems or whatever, then of course this creates a problem that production is going to face at some certain point in time. So by using blueprints and using AI in particular in the form of the IMC, the Intelligent Manufacturing Custodian, provides the user with a wealth of information regarding the problem that occurred and provides also potential solutions. And these solutions are enumerated so that the user chooses the most appropriate solution. And for example, in some cases, the user could interact with the system and propose some changes to the alternatives that have been presented to him or her as solutions. So in that respect, then there's a lot of facilities and a lot of help which is provided to the user so that the user can understand the problem and is in a position to solve the problem with the help of the blueprints and the AI side of Narrate. Armand, to you the button.
Yes, to complete, thank you, Mike. I tried to complete the presentation, and the answer of Mike is very, very complete. But I try to give maybe some example to show what could be the usage of digital twin in industry. So first, we need to transform a physical model into digital model. It could be a representativity of physical model. It's the first aspect. We need also to have the connection to several information system and IoT to receive the data. It's the next step. And finally, we have to and we need to supervise by digital twin or digital shadow, supervise the system. And it's just supervision. But digital twin go a little far from this aspect, and we construct the decision. So we need to have the model, the AI approach, mathematical approach, and so on, in order to transform the data we receive into decision. So we talk about digital shadow, and the last point is also the possibility to involve and to implement this decision directly in the system if necessary. Sometimes we need to discuss with a decision maker and having a decision maker in the loop, and sometimes we don't have enough time. We have to implement the decision as soon as possible. And for example, for CNC machines, for 3D printers, we don't have enough time to validate the decision. When we talk about digital twin, we have several levels, several layers, and several aspects. The objective is at least to help the decision maker in order to observe what's happening in industry without going directly to a manufacturing system and observe physical system, at least to have a good vision of physical system. The next step, having the information and construct the decision, and the last point is implement this decision, sometimes automatically, sometimes by validation of human decision maker.
Jesús, so you are implementing the Intelligent Manufacturing Custodian, and Maurizio, you provide the IoT and cloud support to keep it running. What's the biggest challenge in making sure all these different devices and sensors stay connected so the IMC can act as a reliable nerve center?
Yes, maybe I can start describing the fact that main challenges are around the fact that we always need connectivity and application availability and a trustworthy end-to-end and providing data quality to the IMC on regular basis across very heterogeneous and distributed landscape and sensors. And therefore, we have to provide interfaces with protocols at very different size, but also being able to react and adapt to these data flows whenever a disruption appears, or whenever, for example, a machinery provides data which are not expected. And these expectations and the level of analytics that we can have at the very edge, or very close to the IoT, are peculiar. So we need to have a way of providing constant flow to the IMC, so the IMC knows exactly where and how the product is being manufactured, shipped, or expected parts are coming, and if a missing part is happening on the shop floor, or due to the fact that possibly an RFID has not been scanned, or in a warehouse the depletion of a reference is going on, well, a proper scenario can be activated, and much reliance is put in place at manufacturing level, which is one of the main goals of the IMC itself.
Yeah, thank you. In fact, nothing more to say from the IMC's perspective. As the only thing I could add on this topic is that we need a very, let's say, a very thorough monitoring from the IoT devices until the last step before the IMC gets the information. So, as Maurizio was saying, the availability of the communications, the response of the communications must be at a very high level. Otherwise, if the IMC doesn't receive that specific data, those specific alerts or events coming from the CEP, for example, the magic sort of cannot start. We cannot start with a planner orchestrator looking for the NSQA, talking to the blueprints, because we don't have anything to start. The trigger is, in fact, the information coming from the IoT devices. So I think that the most important thing is to have that monitoring across the from the edge computing below. So then we have that in case anything happens at any point, we can act quickly and reestablish that communication, that specific sensor, so we can keep going. We can keep track and traceability on the on everything happening at the factory, at the production area.
So, like everyone, the goal is self-adaptating network. If a machine breaks down mid-shift, what is the very first thing the narrate system does automatically before a human even has to step in?
Okay, I can summarize it because at the end of the day, it all goes through the IMC. I mean, sort of summarizing, not going very step by step, but if there's a machine that breaks down, there's going to be some sensors that will detect that something has stopped. Then that signal, it will go through the IoT system, through the CEP, that will detect that whatever the data that we've got there is out of range. If it's out of range, they should go through some rules and create an alert. That alert will be sent to the IMC. The IMC will receive that alert in the form of an event, and it will look for we've called that event. It will look for in the platform area. It will share the event to the NSQA. Say, hey, we've got this event. Is there any risk type associated to that event? And also in parallel, there is any response plan associated with this type of risk. With all that, it will build a plan. Will build a plan through the planner. Once it's built, we'll share with the orchestrator. The orchestrator will execute all the actions in that response plan. In the case that, for example, is something new, it never happened before, or we didn't have it into our radar, the planner and the NSQA themselves, they will create a plan from scratch based on the risk happen on that machine, and execute the respective actions and store. Because we're talking about an event, there's no one listening on the other side. The event is, and the conversation and all the actions happen within the IMC. They will be stored they will be stored in a platform library or in a database. So what happens there? No one is being alerted on that. So at the same time, in parallel, once we've got the proposals on the what to do next, an email as an alert email or an SMS via mobile should be sent to the respective person, to respective maintenance people, the operator managers or whoever we decide. So then they are alerted on what's happening on that machine at this stage. I mean, in the response plan, there could be, if there's a machine failure, if we've got established what's that machine, then we could enter into production reconfiguration or other kinds of activities internally in the IMC as a proposals to the decision maker, operator manager, etc.
Yeah, I think the answer of Jesús was quite comprehensive. What I would like to add here is another dimension of narrate. In narrate, we take an anticipatory approach. So in a sense, we anticipate that disruptions are going to happen before they happen. So if the machine breakdown occurs, then this is far too late. So basically what we try to do here, we observe, for example, the signals that we get from the machine, for example, let's say temperature or missing cycles or whatever, and then we predict that this machine is going, at some point, is going to break down. So before it breaks down, we take into account, let's say, all these consequences that were discussed previously by Jesús. So this is an important element. We are one step ahead, and you try to think what may happen, analyze scenarios, and on the basis of these scenarios, propose different types of approaches, replacing one machine with another, or, for example, going outside your organization and finding another supplier, for example, and things like that.
That concludes our look into self-adaptation. It's clear that the leap from standard supply chain to smart manufacturing network is powered by data, but is governed by intelligence. Thank you very much, Mike, Armand, Jesús, and Maurizio for sharing the technical roadmap of the Narrate project. If you're a developer or a manufacturing executive, we hope this episode gives you a clearer picture on how these technologies are being applied in real-world production environment to drive circularity and sustainability. Next time on Narrate Talks, we will be focusing on the Narrate approach, innovative solution, and expected outcomes. Stay resilient.